My name is Steve Lowndes. I'm from Enchaus Networks. I'm my partner.
I am Pasani Shanta from Sri Lanka Telecom. I am Deputy General Manager. I'm Deputy General Manager, IT Solution and DevOps.
Okay, so I'm going to spend the next 20 minutes explaining what we achieved in this catalyst. The premise behind the catalyst was no network is fully predictable. You know, there will always be some event where a person doing some work in the road digs through a cable unexpectedly. There is no way to predict that. But there are huge volumes of events in the network that we believe we can actually predict. And we will prove this as part of the next 20 minutes. But not only can we predict them, but we can then take action to automatically resolve them. And the concept behind this is that if you can avoid a problem occurring, then you can actually avoid all of the associated problems with that, which are, you know, your customers start to get frustrated with you, you start to have issues with CSAT, you start customers calling the contact centers because they have these network problems, which all incurs costs and you lose revenue. So what we did is we came up with this premise that we can essentially replicate what happens within the knock now, but attempt to replicate all of this and use predictive algorithms to try and understand what is going to happen before it's going to happen. So we predict that the issue is going to occur. We identify how to resolve the problem with information from pre-existing tickets, knowledge bases, etc. We apply a fix to the network. So we push some configuration changes down, some provisioning requests to the network to alleviate the problem. And then, of course, we have the ticket being resolved, and it's good practice in any AI environment, we actually learn from that process as well. So the people involved in this and what we try to achieve. Obviously, we're trying to move towards a much more automated way of managing the network. And some of this is based on the idea that the network is now getting to be as complex as it's ever been, and is going to get more increasingly complex over time. So we need to find different ways of being able to fix and manage this infrastructure. We actually use real network information. So the information that we used came from our champions. Both our champions provided a wealth of OSS information, and we use that as part of this catalyst. And that's really important because obviously simulated data really doesn't provide some useful, interesting outputs. And we proved that you can actually automate changes to the network as part of this ecosystem. And the people that we used in this, we had Du from the UAE as one of our champions, and Sri Lankan Telecom as the second. Both of those provided data, as I said. We have Enchaus Networks, where I'm from. We provided the platforms themselves, the AI smarts around this, along with Florida Institute of Technology. And we had NetIce, who provided the change management, the configuration management, and the service provisioning. And we came up with some use cases. I'll explore these in a little more detail later on. But one of the use cases that we found was there are threshold crossing events that happen in the network all the time. The ones that we focused on for this exercise, for this use case, were around threshold crossing events for a mobile backhaul network. And we were able to predict to a really high level of accuracy when those threshold crossing events were going to happen. Now, most people think that with people moving around and changes to network infrastructure and traffic accidents or something occurring in the network, that this is really not something that's predictable. But we managed to find that we could predict with 99.98 degrees of accuracy when these threshold crossing events were going to occur, which is extremely high and actually really surprised us as well. So we then came up with a conundrum, because the conundrum now goes from can we do this to the ecosystem itself. The broader ecosystem is that there is network operations center. There are people that are actually sat there trying to resolve these problems, and there's lots of processes around change management, around auditing that need to go on as part of this ecosystem. So then you start to encounter some more political, organizational questions about what are the right kind of levels of confidence that you would have to have within this ecosystem to be able to push those changes down, to make those changes, to resolve the problems that you've predicted are going to happen. So these are probably too low, I suspect, for any organization to start with. So I think that if we move to 99%, maybe as this first level that you would be comfortable with to try and automate some kind of changes in the network, but that's probably, I think, something that most carriers would be comfortable with. And then maybe as an alternative to actually making that automatic change to the network infrastructure, you could create a ticket and get a human to approve a change or make the change themselves. And then the last kind of level that we looked at was creating a fault or enriching an existing fault to inform the people within the NOC that there was this potential problem that was going to occur. Okay, so I always think it's important to try and put alongside the technical and environmental concepts with what are the real business benefits that you're going to achieve with this. So we have one of our champions here on stage. I thought it was very useful to him to explain from his perspective, what are the business benefits he expects.
As currently Sri Lanka Telecom has a very complex network. Actually, it is old, more than 100 years. And it contains new and legacy networks as well multi-vendor network. That once something happen in the network, our NOC team itself cannot fix the issue. They have to get the operation team and the network team support as well. Sometimes they spend hours to find out the root cause. That is the key problem, and they always ask IT team to give some solution to this one. They themselves can't figure out the root cause. But finally, it will impact to our corporate customers. Sri Lanka Telecom is the main service provider in the whole corporate customer throughout the island, in all the key customers. So we get more revenue, more than 80% from the corporate segment. Because of that, once I joined this project, I want to reduce this problem identification to few minutes, reduce from hours to a few minutes. Then we can improve our SLAs, we can improve our, we can reduce our churn, and we can have a better corporate image. So that is my contribution. This project, we provided all the real data. So we hope, top of that, they build the solution.
Thank you. So I've put this into 2 slides to explain the ecosystem that we're expecting to impact. But I thought it was worth level setting that every operational organization has to try and derive some kind of efficiencies. It's always a pressure, regardless of whether your data is growing, your network's evolving and expanding, you're always tasked with trying to reduce cost. So this is a constant. However, what is changing, as we've seen everywhere at the show, for the last few years, 5G has obviously been a big driver for change. NFV is deployed in many places now, and he's probably classed as mainstream technology. SDN is very much coming within the next 6-12 months. So all of this kind of change within the ecosystem means that we're now going to have far more devices and far more applications which are really sensitive to things like latency. So 5G services being sold as this, low latency kind of ecosystem. If you're getting lots of retransmissions because you've got really small problems where you've got loss of frame or something on a transmission infrastructure, and you can actually try and resolve that, then it's really necessary to even think about doing those kind of things in this new ecosystem. And of course, your customer demands are shifting. So again, this is nothing new. This always happens. But those kind of low latency services that they're going to expect to have, on demand are all part of this new ecosystem and expectation. But from a financial standpoint, we postulated that one of the biggest impacts from a cost standpoint was if you can actually avoid network outages by being able to predict some of these changes and be able to proactively resolve them before they impact the customers, you will start to see a reduction in this metric. So 3 to 10% of all calls into the contact center tend to be around network quality or network service. This is a number I've heard from many carriers within this range. So how many people do the carriers have within their contact centers now? If they can reduce that even by a small number, then that will have a real impact from a cost perspective on that carrier. Another metric that's very, very often used is mean time to repair. Mean time to repair, though, to me is one of several metrics that should be used in the future. Another one that I'm suggesting we use as part of this catalyst and hopefully within the forum more is mean cost to repair. This isn't currently in any of the guidebooks. It's a metric that is seen more, I think, on the IT space. But considering every problem that there is that needs fixing costs something, then to me that's an obvious way of trying to understand the impacts of this kind of ecosystem within the cost base. Okay, so much more detail about the Catalyst project then. So the information that we took from the carriers, from our champions, were fault information, ticketing information. The fault information had things like threshold crossing events in there, so it is to a limited degree performance information as well. And just to give you a kind of flavor for the type of information that we got 3 months worth of information which covered 2.5 million events for a subset of their network and 8,500 tickets during that timescale. Now, that's a very large mismatch, but is not unusual. So that equates to 0.3% of faults resulted in a ticket, which essentially means these networks are extremely chatty. And I'm sure anybody who's worked in these ecosystems, that is not a surprising kind of number. However, an interesting question is, how many of those events that came in could they have done something about? Even if the impact, the actual customer impact would have been minor to resolve that, how many of those faults could they have done something about? So as part of the machine learning to try and understand, could we predict what faults were going to happen, the data scientists within the team used decision tree algorithms, but we found that there was little linkage between the faults themselves and the tickets. So trying to automate that kind of linkage that said there has been these events in the network and these tickets were generated as a result of that. In the data sets we had, we couldn't ascertain that link. I believe that in other data sets you would be able to do that because there are many systems where service assurance platforms will automatically raise tickets in ticketing systems by operator actions, right mousing on an alarm, for example, and creating a ticket through an API. So I think in some data sets that would be possible. But one problem that we found, and again, I think this is extremely common in this ecosystem, was that the information that was contained within those tickets to try and use as a basis for a process of resolution really didn't exist. In most organizations where they are running these kind of ticketing systems, there are very few quality measures, very few checks that the information that is contained in those is in any way representative of what actually happened. So we found that we really couldn't use the information within these data sets, and I postulate that that's probably very similar in other data sets. So that leaves a hole within this whole machine learning ecosystem, because you cannot try and identify how to resolve something based on the data sets that we have now. And we set up this ecosystem using an Azure cloud solution. There are predefined data science virtual machines, so we use that as the basis. We had API set up into the NetIce platform, which is what we used for the automatic configuration changes. And they pushed the provisioning down to a simulated network. But this is all based on the real information that we got from our champions. So in the broader context of how this would look in the future, to me, this opens up a much broader architecture for AI within a service assurance ecosystem. So we have the typical OSS sources. So just like we've had for this catalyst, you have the fault, the performance, you can bring in the provisioning system, and you can have the ticketing. But there's no reason why we shouldn't also bring into this the external factors that we now are able to get information on from various published APIs in the public domain, such as public events or weather, or even things like road traffic accidents, which smart cities have started to publish. So if you can bring all of this information into this ecosystem, you're then much more informed not only about the predictability of the alarms themselves, but also in some cases what the problem is that is causing those. And that can also inform how you would try and resolve these. So we didn't try and deliver this ecosystem as part of this catalyst, but given what we learned, this seemed to be a sensible architecture to try and move it forwards in the future. So given a kind of breakdown of the kind of events that we saw, we had the biggest problem reported in this transmission infrastructure was port utilization. So this is a threshold crossing event that happened. This was 13% of the faults, the total faults that were delivered in that data set. And you can see many others are linked to the microwave. So 80% of all of these problems in that data set were linked to 15 types of events. So you don't have to try and find 50 different problems that you can automatically predict and therefore resolve. Even a small number will actually have a significant impact on this ecosystem. And what we found, as I mentioned earlier, on those threshold crossing events, we found that we can predict with an extremely high level of accuracy when those threshold crossing events are going to be created. So if we understand beforehand, we postulated and showed that we can predict that there is an event about to happen with an extremely high level of accuracy. We can then make a change to the network infrastructure to alleviate the problem. So in this case, this is probably a layer 2 VPN that's crossing an IP MPLS core. So for the duration of the problem, we can actually, for example, increase the bandwidth of that layer 2 VPN connection. Now this could be driven, this threshold crossing event could be driven by a gathering, a meeting that always happens, or some road traffic that tends to occur always at the same time, every Friday. So these are not kind of things that you want to be able to try and just increase the bandwidth of the connection constantly. So you may actually just want to increase the bandwidth of that connection for a limited time and then reduce it again afterwards. So what we learned from this is that we really can predict some events, not all, but some events. The highest that we had was that 99.98%. The lowest out of the faults that we checked were 74%. One of the issues that we found in this ecosystem is the quality of the information in the ticketing system. And I think the gold dust that you would try and search for going forward is that you can define any number of use cases to try and reflect how you can make impacts within this AI ecosystem on the network operation. So in this first phase, we actually use the fault and the performance or threshold crossing events. In the future, when we take this forward, we are going to try and find a source where we have some ticketing information, or at least some references out to some knowledge bases. That means that we can prove that closed loop will actually resolve the problem. Potentially bring in additional sources of information, such as road traffic information, which I mentioned is published by some cities now going forwards. And I'll finish by just presenting some of the metrics that we expect are going to be impacted by this ecosystem. You can see a lot of them are based on cost or customer retention, customer loyalty. So we think that these are probably the biggest impacts as we move forward to a 5G infrastructure. Thank you. Any questions? Yes?
Can you talk to the quality of the trouble ticketing? I mean, what impact would it have? Maybe you had better quality ticketing. Would that have impacted your outcomes or the results of your...
So the question was, if we had better quality ticketing, would it have affected the outcome, the catalyst? I would like to think so. If you have an ecosystem where there is a huge amount of knowledge within a repository, and you can actually take advantage of that repository to be able to try and use as part of this learning ecosystem, then I think it would mean that you could very quickly start to diagnose problems a lot quicker. And you're not reliant on the smarts or the intelligence of the engineers to try and inform these processes. Any other question? No? Thank you.